Hi guys, thanks for tuning in. This video that we're going to do today is going to talk a little bit more in depth about the limit definition of slope as it pertains to derivatives, or the introduction of derivatives in my calculus class in section 2.1. So what we want to do is let's kind of start off here and talk about what we know so far in terms of slope. So if I just draw, this is what I did in class here. I got my x and y axis here. If I draw a line or like a curve here, and I know that if I take 2 points, and let's say like right here and right here, and if I connect those, see if I can draw a straight line here, but if I connect these 2 points, what you did a ton of in Algebra 1 is you found the slope between 2 points. And what I want to do here is talk in general here. If I have a point xy right here, and then to get to this point over here, I have a different x and y coordinate. Well, I'm going to use function notation. So instead of y, I know from Algebra 1, y and f of x are the same thing. So I've got that first point. Now, to get to this next point, I know that I have to go some distance of x to the right and some distance of y up just to get to this other point. So what we do is, if you remember from Algebra 1, the Greek letter delta, that means change. And if you remember from your slope formula, that delta x, that's your change in x, and delta y, that's your change in y. So what I'm going to do now is, to get from this x to this x, I'm going to say it's x plus some other width of delta x that we went. And to get from this y up to the next y, I've got f of x plus delta x. And so now what I want to do is I want to apply the slope formula. If I remember the slope formula from Algebra 1, I know that that's y2 minus y1 over x2 minus x1. So if I treat this as x1 and y1, and this is x2 and y2, I'm going to apply that to the slope formula. Let's kind of see what happens here. So let's start off here, y2 minus y1. So that's going to be f of x plus delta x minus y1. y1 was f of x, all over x2. Well, that's right here. That's x2. So x plus delta x minus x1, which was just x. And we'll see down here that the x's right here just cancel. And what we're left with, and if you've done this in Algebra 2 or Pre-Calc, you will see that we have what we call the difference quotient left over. And for people that are in my class, they'll notice that this is the bonus problem in pretty much every Pre-Calc test that led up to this point. Now, so this difference quotient actually means slope. And that's the slope of the secant line. When you hear secant line, that just means you're finding the slope of a line that has 2 points. Now, the whole purpose of this here is we want to go from 2 points and we want to kind of graduate to 1 point. Okay, so we could kind of visually see here that there's going to be a point somewhere in here on the curve where the slope of, when we talk about just intersecting once, the slope of the tangent line is the same as the slope of the secant line. All right, so we want to take this difference quotient and we want to try to put some calculus with it here. So what's happening to the x value as we are going from this point to this point, and then from the right side here? We're actually squeezing it down, and the distance between the x's there, or the width of x, is getting smaller. So how do we say that in terms of calculus? Well, what we did in all of Chapter 1, we're going to say that the limit of the width of x, or delta x, gets really small, which means it approaches 0. So this whole thing right here is the way you find the slope of the tangent line, by applying the limit to the difference quotient. And this is what a derivative is. And I know my class, we have to say it over and over again. The derivative is the equation that represents the slope of the tangent line found by using this difference quotient. So let's apply this. Let's apply this and kind of see what happens here. So what I'm going to do here, let me scroll down. Let's do something that we all know how to do. For example, we all know slope-intercept form, right? You have that from Algebra 1, y equals mx plus b. So let's say I have something like 2x plus 4. Now, I know everybody going into this, if you have any kind of background in algebra, we know right away that our slope is 2. I want to prove that with that limit definition of a derivative. So I know that that's the limit as delta x approaches 0, and that's the difference quotient then. So f of x plus delta x minus f of x all over delta x. So when you apply the difference quotient, you have to do this part first, this part second, and then you got to simplify some things. So when you do this first part, f of x plus delta x, that means you take the original function, and wherever you see an x, you're going to plug in x plus delta x. So here's what I'm going to do. I'm going to try to color code this for you. So we're going to have 2, and then I'm going to plug in x plus delta x, because I replaced the x that's right there. Okay, and then plus 4, and then minus the original. When you subtract the original, you just take the original right here and just flip all the signs. So instead of positive 2x plus 4, it's going to be negative 2x minus 4. And this is all over delta x. So now you normally have some algebra to do here. It's usually with the x plus delta x's, and you have to expand it or distribute. So I got to distribute here with the 2. So when I do that, I'm going to have 2x plus 2 delta x plus 4 minus 2x minus 4 all over delta x. So now, if you do this right 100% of the time, if you did this right, the second part here that you subtracted should cancel itself out. So let's take a look here. I got negative 4 and positive 4. Negative 2x and positive 2x. And then what do I have left? I have 2 delta x over delta x. And again, those cancel. And I'm left with just 2. Now I can't forget here what was at the very beginning of this, and that was the limit. So I have the limit of delta x as it approaches 0 of just 2. And if you remember your properties from section 1 or chapter 1 of limits, the limit of any constant is itself. So we did get an answer, or a slope, of 2, which matched. So this was the algebra 1 way, and here's the calculus way by applying the difference quotient. Now, are we always going to deal with a line? No, we're not always going to deal with a line. So let's take a look at something else here, where we just start off. Let's start off with a really basic quadratic. So how about like just f of x is equal to x squared, and we want to know the derivative, or the equation that's going to represent the slope on that quadratic or that parabola. So again, I start with the limit definition. Delta x approaches 0, f of x plus delta x minus f of x all over delta x. Alright, so I apply x plus delta x to the original function. So I'm going to have x plus delta x squared. Subtract the original, so that's minus x squared, and that's all over delta x. Okay, so now you gotta do some algebra here, and hopefully this has been told to you so you don't have to FOIL this every time, but you do have to FOIL it. Don't distribute this. That's not how you do it. You know, you got to FOIL that. Okay, so x plus delta x squared is x squared plus 2x delta x plus delta x squared, and then minus x squared all over delta x. So again, if you did this correctly, the original that you subtracted should cancel itself out, and you see that we have the x squareds there that cancel out. Let's take a look here what we have left. We got 2x delta x plus delta x squared all over delta x. Now, when you get something past a linear, this next step also always happens. Just like here, you should always cancel out your original. Here, everything in the numerator has a delta x. So we're going to factor out a delta x, and we're left with 2x plus delta x all over delta x. And the reason we do that is we want to cancel out delta x's on the top and bottom. And then we go back to the beginning here, which we have a limit. We have the limit as delta x approaches 0 of 2x plus delta x. And now we're allowed to do direct substitution. So 0 goes in for delta x. So we're left with 2x. 2x is our derivative. The derivative, again, is the equation that represents the slope of the tangent line. That's f prime of x. We can also write that as y prime, and we can also write that as dy dx. But this 2x that's right here, this represents the slope of the tangent line at any point on x squared. Let's look at that a little bit more closely here. If I have x squared, we know that that's a parabola. Okay, so that's a parabola right at the origin right here, okay? If I pick a point anywhere on here, let's say I pick here like that at x equals 1. At x equals 1 right here, I want to know the slope of that tangent line, which is right here. I'm going to take this 1 and plug it into my derivative, because this is the equation that represents the slope. So to get the exact slope, you plug in the x value. So 2 times 1, the slope right here at this point is 2. And it should make sense that the wider we go, the steeper we get. So let's pretend here like this is way out here at x equals 5. So 5 times 2. At the point 5, we're going to have a really steep tangent line right here. The slope is 10. And we know that if we go to the left here on the x-axis, let's say that at x equals negative 2. At negative 2, we're going to have a negative slope right here. And that's going to have a slope of negative 4. So this was finding the derivative, and then we actually found at certain points on the graph there what the slope would be by plugging in the x value here. Let's just finish this off with one more problem. And we'll do another quadratic, but we'll do one that's a little bit more complex. Let's say we have f of x is equal to 2x squared minus 3x plus 5. Okay, so we got some algebra in front of us here because we're going to apply the limit definition for a derivative. Okay, so let's say that the directions are a little bit more complex as well. So given this, f of x is 2x squared minus 3x plus 5, they're asking us to find f prime of 1. This is just fancy notation of saying find the derivative and then plug in 1 and find the slope. Okay, so sometimes they'll give it to you like this. Sometimes they'll give you an x and y coordinate that goes with it as well. So we're going to start off again, the limit definition with the difference quotient, f of x plus delta x minus f of x all over delta x. So it starts by taking the original function and plugging in x plus delta x. So I'm going to try to color code this for you here. We're going to have 2. And then we're going to replace the x with x plus delta x squared minus 3. And then again, x plus delta x. And then finally, plus 5. And then we're going to subtract the original. So when we subtract the original, we're going to flip all the signs here. So it's going to be minus 2x squared plus 3x and minus 5. And this is all over delta x. Alright, so what we have to do now is we have to be able to expand this and distribute this and then see if things cancel like they're supposed to. Alright, so first things first. I got x plus delta x squared. So I'm going to have 2 times x squared, 2x delta x, and delta x squared. That is this quantity expanded. I'm going to distribute a negative 3, so I'm going to have minus 3x minus 3 delta x. Don't forget the negative 3 to both there. Plus 5, and then minus 2x squared plus 3x and minus 5. Now I'm still have a little bit more algebra to do. I got to distribute this 2 here to everything. Okay, so I'm going to have 2x squared plus 4x delta x plus 2 delta x squared minus 3x minus 3 delta x plus 5 minus 2x squared plus 3x and minus 5. And I got to draw this all over delta x. All right, so a lot of algebra there, but not too bad. Okay, so now let's see if everything cancels. The whole right side here that we subtracted right there, that's got to cancel out. So let's start at the very far right. Negative 5, hopefully there's a positive 5. There it is. Plus 3x, do we have a minus 3x? Yep, there it is. And negative 2x squared with a positive 2x squared. Excellent. So we know we did that right. Okay, now what's next? We got to make sure that everything left over has a delta x, and let's see, it does. And the reason why is because we want to, every term in the numerator has a delta x, we want to factor that out. So we're going to take out a delta x, and we're left with 4x plus 2 delta x and minus 3. We take out that delta x because we want that to cancel with that denominator, and we're back to at the very beginning that whole limit here as delta x approaches 0. So I'm going to change it up, nice little color blue here. I got the limit as delta x approaches 0 of 4x plus 2 delta x minus 3, and direct substitution tells us that this is 0 right here, and so our derivative is 4x minus 3. That is our derivative. And now, they asked us way back at the beginning, what is f prime of 1? So what's the slope at 1? So again, the derivative is the equation that represents the slope. So therefore, to actually get the slope, I'm going to plug in the 1 that they asked us to. And by plugging in 1, we can do some mental math here. 4 minus 1, or 4 minus 3, 4 times 1 minus 3. That's going to get us a slope of 1. So hopefully that kind of explains the limit definition of a derivative. And thanks for tuning in.